Hello and welcome once again to Plumbing's Cool, and this is how you braze. Brazing, which may also be referred to as hard soldering or silver soldering, is a little bit different than traditional soft soldering, which utilizes a softer, more flexible metal alloy known simply as solder, and requires much less heat than brazing does. This is why brazing is preferred for high pressure and stress applications, such as refrigeration and underground copper connections. Brazing will require the following items: an acetylene gas tank and respective torch, which burns extremely hotter than your standard propane or MAP gases. This excessive heat is necessary for raising the materials to a temperature hot enough to melt the brazing rod, which begins to flow freely at approximately 1300 degrees Fahrenheit. Next required is a rigid filler material known as brazing rods, sometimes referred to as Silphos, which is actually the brand name for variety commonly used in North America. Regardless of brand, what's important is that the brazing rods are made up of the proper combination of materials. Much of the brazing rod consists of copper, but it also contains phosphorus, which acts as a fluxing or cleaning agent and eliminates the need to add a separate solder paste when soldering copper to copper. Silver may also be added, up to 15%, which helps to significantly strengthen the joint. Brazing rods can easily be purchased at your local plumbing or HVAC supplier. And finally, you'll also need a method to clean your copper surfaces to be joined, which can easily be done using standard grit or sandcloth, as well as metal fitting brushes made for the purpose. Doing so will help assure that the material sticks to the surfaces. So brazing is a little bit different than soldering in the sense that soft soldering using regular 95.5 or lead-free solder requires much lower heat and requires cleaning of the materials in addition to more preparation. When you're brazing, we don't need solder paste to make the Silphos adhere. So let's start up our torch. It's a little noisier than your standard propane. Yeah, no kidding. Because of the acetylene torch's deafening sound, I decided to spare you the agony of bleeding ears by cranking down the recording audio and narrating from here on. One major thing which sets brazing apart from traditional soldering is that the copper pipe needs to get extremely hot, often glowing red, in order for it to be able to melt the brazing rod. Therefore, it's important to let the pipe do the melting and not the torch's flame. So be sure to keep the rod out of the torch's path while you proceed to heat up the pipe. Admittedly, I'm using a relatively small tip for the size of pipe we're brazing to. In this case, 1.25" nominal pipe size. A larger tip would emit more heat and therefore heat up the pipe more efficiently and quickly. But as you'll soon see, this torch tip will still do the trick. Plus, the longer heating time will allow me to explain a few critical points while you get to watch a pretty flame dance around. Point and move your torch tip evenly around the area where the two sides intersect. This is the thickest area and will therefore require and absorb the most heat. As you keep moving around, applying heat in a smooth fashion, you'll begin to see the pipe discolor and even appear to be charring or burning. I can assure you that this serves no harm to the copper pipe, so don't be alarmed if your nice shiny copper surface begins to look ugly. But let's not judge. To test whether the joint has reached the appropriate melting temperature, periodically tap on the joint's intersection with the end of the brazing rod. If the rod melts on contact, then the joint is hot enough. A surefire way to tell if the pipe is ready is when it begins to glow red. Another thing that sets brazing apart from soft soldering is that soft soldering is much more forgiving when removing the torch from the material. Specifically, that the pipe remains hot enough to melt the applied solder seconds after the torch tip is moved away. Not so with brazing. Removing the torch tip while applying the brazing rod will cool the filler material quickly enough to almost instantly cause the rod to get stuck to the surface. Therefore, brazing will require more consistent and finicky application of heat. However, with some experience, you will get the proper feel to know when to back off the torch and when more heat is required. This is specifically useful if you want to build up the filler material. When the joint is finally hot enough, which is around a balmy 1300 degrees Fahrenheit, the joint will begin to literally suck in the solder via a naturally occurring phenomenon known as capillary action, which is a really cool topic that deserves its own discussion for another day. Continue to apply the filler at the joint intersection in a smooth motion, almost as if you were applying detailed strokes of fine painting, all while pointing the flame consistently around the same area so as not to cause the joint to dip below the melting point temperature. Note that once the gap between the pipe and the fitting is filled, it will cease to dry on any more filler material, which will likely just end up wastefully dripping down onto the floor or along the outer wall of the pipe. As an extra measure, you may want to build up the material by strategically backing away your torch flame while continuing to apply the rod along the joint's circumference. Again, this may take some practice, but you will eventually get the hang of it. Another really cool aspect of brazing compared to soft soldering is that it's much easier to visually inspect a braze joint for any leaks or pinholes, which are more obvious. If you do find any questionable imperfections, simply fire up your torch and reheat and touch up the area of concern with additional brazing material. And as always, be sure to leak test your connection. And I think that's a pretty good joint. Now, we're not going to touch it for a few minutes because this is very, very hot. Silphos tends to melt at around 1300 degrees Fahrenheit versus regular soft solder, which only requires about 300 to 400 degrees Fahrenheit, which is the equivalent of the stove that's in your kitchen. So this is hot. As well, what it also tends to happen is that the high heat changes the temper of the copper material, so it goes from a hard copper to a much more flexible and malleable copper. So this is cool. I can tell you that if we do attempt to place Silphos on it, it will no longer melt. Because as soon as you remove that flame, the heat that's required to melt this Silphos drops significantly with the removal of that heat. Now, admittedly, I used a tip that was probably too small for 1¼ inch diameter pipe, but part of the reason that it took so long to heat up is because this 1¼ inch pipe is rather big, and because copper is a conductive material, much of that heat is being taken away by the rest of the material. If this was smaller diameter pipe, if it was all 3/4 inch and all 1/2 inch, it would have been much, much easier and much quicker to hard solder or to braze. Now you'll see that it kind of flakes off a little bit. There's nothing wrong with that. That's just oxidation from using the torch. But one cool thing about brazing is that once you clean off your fitting, you can actually visually inspect whether you have any holes or not. And if you do have any holes, it's just a matter of reheating the connection and filling up those holes. So we don't use this too often in the plumbing trade, but where we do use it, we use it for applications requiring high temperatures or pressures. If we're burying copper pipe underground, and our Ontario Plumbing Codebook requires that if we are burying copper pipe, it must be soft copper piping, cannot be hard copper piping for water service or water distribution. We have to use hard copper piping for drainage because drainage needs a consistent slope. But if we're conveying water pressure, we need soft copper piping, and it must be a brazed connection as opposed to a soft soldered connection. We cannot soft solder for burial. It must be a brazed connection. The other two options for burying copper piping is via a corporation fitting and flared fitting, which is for another video. But typically, we've got a nice joint. And I'm not going to touch it because it's kind of toasty and I like to leave my fingers unburnt. But there you have it. Okay, maybe I'll touch it a little bit. And so that's how you braze a copper joint. If you like this video, please be sure to plunge that like button and subscribe to this channel, Plumbing is Cool. Please feel free to leave your comments in the section below if there's anything you'd like to see in the future, and I'll try to make it happen. Meanwhile, I'll see you next time.